So today we're talking about comparing and ordering real numbers. Let's look at the warm-up that you guys just did before we get started. Courtney and Malik are buying a rug to fit in a 50 square foot space. Which rug should they purchase? And explain. Okay, so it's a $99 rug sale, so all three of these rugs cost the same amount of money. Okay, but they need their rug to fit into their 50 square foot space. So it can't be bigger than 50 square feet because that's all the space that they have. So let's see the three different options and see which one will better fit their space. Okay, so here are the three formulas for the area of a circle, square, and a rectangle. So let's look at the circle. Because we are trying to compare these different measurements, we do want to use 3.14 for pi. So I'm just going to fill in 3.14, and if I'm looking at the circle rug, this is an 8-foot diameter. I need the radius. The radius is half of the diameter, so the radius is 4 squared. And we know that 4 squared is 16. So if you multiply 3.14 times 16, you're going to get approximately 50.24 square feet. Okay, let's go look at the rectangle and the square. The rectangle is length times width. So we know that the length is 6 and the width is 8.5. Okay, if we multiply those two together, we will get 51 feet squared. Okay, now let's look at the square. Okay, so the square, the formula is side squared. The side of the square is 7, so it's just 7 squared, which is 49 square feet. And looking at all three of these, the only choice there is that's under 50 square feet would be that of the square. So this is the one that Courtney and Malik should purchase. Make sure that you write your answer down because it did ask you to explain, so you need to use sentences to explain. Okay, as well as be able to back it up with your work that we have over here. Okay, let's move on to today's lesson. Comparing and ordering real numbers. How can you compare and order rational and irrational numbers? This is the essential question that we're going to be answering in this lesson, and we will come back to that when we're finished looking at all the examples. So keep that in mind in the back of your thoughts. How can we do this? Let's look at example 1. Darcy wants to add the ribbon shown along the diagonal of the rectangular flag she is designing. Does Darcy have enough ribbon? Explain. Okay, well here's her diagonal right here, and it is the square root of 74. I want to take a moment and pause and talk about some different square roots, so let's talk about this for just a second. Okay, let's talk about the ones that we know. Okay, we know that the square root, whoops, we don't need to be writing in stars. Okay, so we know that the square root, the first thing that we know, the square root of 1 is 1. And let's talk about what we know about these square roots. Let me write this at the top of the page so we can actually see. Okay, so let's look. All right, so the square root of 1 is 1 because we know that 1 times 1 is 1, right? So if you take the square root of 1, you're going to get 1. The next perfect square root is 4, and the square root of 4 is 2 because we know that 2 times 2 equals 4. The next perfect square root that we have is 9. Okay, the square root of 9 is 3 because 3 times 3 is 9. Okay, the next one that we have is 16, and the square root of 16 is 4 because 4 times 4 is 16. The next one would be 25, which would square root of 25 is 5 because 5 times 5 is 25. And the square root of 36 is 6 because 6 times 6 is 36. So if I asked you a question and I said, where would the square root of 18 fall? Where would the square root of 18? It would come somewhere in here. in between the square root of 16 and 25 because 18 is between 16 and 25. But the question is, it's not perfect, so you know it's going to have a decimal. And what would it be closer to, 16 or 25? Okay, 18 is closer to 16, so the answer would be closer to 4. So the answer is between 4 and 5, but closer to 4. Let's look at some examples of this. Okay, so looking back here at Darcy's flag, she wants to put a diagonal ribbon right here. And the length of the diagonal is a square root of 74. Let's talk about how we can do this. The first thing we're going to do is approximate the square root of 74 using perfect squares. And why must you approximate the square root of 74? Square root of 74 is not a perfect square. It's irrational. A rational approximation must be done in order to compare the numbers. Okay, so because 74 lies between the two consecutive perfect squares, 64 and 81, square root of 74 is located between square root of 64 and the square root of 81 because 74 is in between these two numbers. Okay, and we do know that the square root of 64 is 8 and the square root of 81 is 9. So the square root of 74 is somewhere between the numbers 8 and 9. Okay, so is 74 closer to 81 or 74? Okay, it is closer to 81. So the square root of 74 is closer to the square root of 81, which is 9. So it's closer to 9 than it is to 8. So is knowing that the square root of 74 feet is between 8 feet and 9 feet enough information for Darcy to know whether she has enough ribbon? Explain. Okay, well, she has 8.5 feet of ribbon, and we know that the square root of 74 is between 8 and 9, and so is 8.5, so that's really not enough to explain it, so we kind of need to look into this just a little bit more. So let's look and find a better approximation by squaring decimals between 8 and 9, and then we'll compare. Okay, so which decimals can you use to find a better approximation? So we know that we have 8.5 right here, right? And we know that 8.5 is between 8 and 9, so that's a good place to start. So we're going to start with 8.5. So if we start with 8.5, we have that 8.5 times 8.5 is 72.25. Well, that's too low because we're looking at 74. Okay, so let's do the next one. Let's do 8.6. Let's go up. 8.6 times 8.6 is 73.96. So much closer to 74 that we're going to go with that. Okay, so we're going to approximate that the length of the square root of 74 is 8.6 feet. So does this mean that Darcy does or does not have enough ribbon? Okay, so she does not have enough ribbon. Okay, let's look at the next example. Okay, between which two whole numbers is the square root of 46? Which of the two numbers is a better estimate for the square root of 46? And explain. Okay, so let's look at this. So let's talk about what two perfect squares the square root of 46 is between. Okay, it is between the square root of 36 and the square root of 49. So in between there, you have the square root of 46. Okay, so we all know that the square root of 36 is 6. Okay, and the square root of 49 is 7. So we have the square root of 46 in between here. So we know that it is between, and I'm just putting these less than signs. So 6 is less than the square root of 46, but the square root of 46 is less than the square root of 7. Okay, so, but what is this? Okay, so we are in between 6 and 7, but those are our two numbers in which they're between, but which of the two is a better estimate for this? Okay, so which one would it be closer to? Is 46 closer to 36, or is 46 closer to 49? Okay, it's closer to 49, so therefore 7 is going to be the better estimate for the square root of 46, okay? Because it is closer to 49 than it is to 36. Okay, so the two numbers which it is between are 6 and 7. And of those two numbers, 7 is a better estimate for the square root of 46 because 46 is closer to 49 than 36. So the square root of 46 is closer to the square root of 49, or 7. Okay, I want y'all to pause the video and I want y'all to try this example by yourself and then unpause to check your answer. Okay, here's the answer. It is between 3 and 4, and it is closer to 3 because 12 is closer to 9 than 16. So the square root of 12 is closer to the square root of 9, which is 3. Okay, so let's look at the next example. Here we're going to compare irrational numbers. And I need to compare the square root of 32 and 5.51326, ... Okay, so this is not repeating, it's not terminating, so it is irrational. This right here is not a perfect square, so it is also irrational. I need to compare these two irrational numbers. So we need to plot each number at its approximate location on a number line. So let's talk about how to do that. So we're going to find an approximation by using perfect squares and decimals that are either greater or less than 5.51326. Okay, so let's approximate the square root of 32. Okay, now the square root of 32 is going to be in between the square root of 25 and 36, because 32 is in between 25, just write it right here, is in between 25 and 36. Oops. Okay, so we know that this is in here. Okay, well the square root, and I wrote that wrong. Okay, there, the square root of 25 we know is 5. So we know the square root of 32 is in between, my goodness, I can't write today. Okay, so we know that the square root of 32, I'm just going to rewrite this for y'all real quick, I'm so sorry, all right, is between 5 and 6. Okay, now we're going to use a better approximation using decimals. Okay, so we're going to take our decimals and square them. So we can start with 5.5. Okay, so let me get a different color here going. And if we do 5.5 times 5.5, that gives us 30.25. Okay, not quite there. Let's go up a little. Let's do 5.6. Okay, so 5.6 times 5.6 is going to give us 31.36. Getting there. Okay, so let's do one more. Let's do 5.7. Okay, so let's do right here. 5.7, oops, that's a 7, times 5.7 is going to give us 32.49. Okay, so we're in between basically. We're at the square root of 32. So the square root of 32 is going to fall somewhere between 5.6 and 5.7 because 32 is in between 31.36 and 32.49. Okay, so we're getting a little more clear here. So we do know, I'm going to go ahead and write that down. So we are now between 5.6 and 5.7. Okay, so we've gotten a little more clear. We were between 5 and 6, and now we've narrowed it down to be in between 5.6 and 5.7. Okay, so now step 2 is to approximate 5.51326 as a rational number by rounding to the nearest tenth. So if we round this to the nearest tenth as the first decimal place, this is going to be approximately 5.5. So I'm just going to write, oops, drawing lines all over the place again. 5.5. Okay. So now I want to plot each approximation on a number line to compare. Okay. Let's do that. Okay, so my 5.5, which is my approximation of this 5.51326 right there, is going to go right here on 5.5. Okay, so, and then I know that the square root of 32 is in between 5.6 and 5.7, so that's why I'm going to graph it right here. So this was the square root of 32, and this was just the 5.5. Okay, so now I can compare these two numbers, and I can come up with a solution. And I know that the 5.51326, which kept going on, is less than the square root of 32. Okay, so it is less than the square root of 32. I'm going to circle that for you guys real quick. Whoops. Okay, so it is less than. So let's look at this question over here. Why is it enough to know that the square root of 32 is between 5.6 and 5.7 and explain? Pause this for a second, think of the answer, and then check back to see if you got it right. You only need to know if the number, which is square root of 32, is greater than 5.51326 ... And if that number is between 5.6 and 5.7, you know that it is greater, so that's all you had to know. Okay, so let's move on to the next example. Example 2. I would like y'all to pause the video, take a moment, work this problem out, and then check back to see if you got your answer correct. Okay, so the first thing we had to look at was that 6 is in between the perfect squares of 4 and 9. The square root of 4 is 2, and the square root of 9 is 3. So the square root of 6 lies somewhere in between the numbers of 2 and 3. Okay, so is 6 closer to 4 or is it closer to 9? Well, it's closer to 4. Okay, so what I started doing was I started doing the squares of 2.4. So 2.4 times 2.4 is 5.76. And 2.5 times 2.5 is 6.25. So 6 is somewhere in between these, square root of 6 is somewhere in between these two numbers, 2.4 and 2.5. Then I rounded our decimal up here to the nearest tenth, which is 2.4. Okay, so our number here, the one I just rounded to 2.4, is right here on the number line. The square root of 6 is closer to 2.5 than it is 2.4, so it is bigger than 2.41247. Okay, y'all try this next answer and then pause the video and see, and then replay it to see if you got it correct. Okay, so we know that square root of 53 is between 49 and 64. You can follow along here. And I did the approximate of the squares of the decimals here. And let me just say one thing. If you pick a decimal and your answer is bigger than your number, like if you picked 7.4 and did that one, you would end up with 54.76, which is larger than 53. So you would know you need to go down in your number. So you need to go down to like 7.2. Okay, so then when I did all this, I found out it was approximately between 7.2 and 7.3, so about right here. And then the other number was 7.83638, so it was 7.8 rounded to the nearest tenth. So it's obviously larger than the square root of 53. Okay, so let's look at the next example. Okay, we're going to compare in order rational and irrational numbers. Remember, irrational numbers do not have a terminating decimal and they do not repeat, they just keep going. Okay, so, and rational numbers do terminate, or they repeat the same thing over and over. Okay, so here are our numbers. Remember, pi is irrational. Then you have 9.5, 9.8, 9.5 repeating, and the square root of 94. The square root of 94 is irrational, okay, and pi squared is also irrational. And the other three are actually rational numbers. Okay, so step one, we're going to use rational approximation to estimate the values of irrational numbers. So the two that we're going to look at, the irrational ones are pi squared, but then the others are fine. So let's go ahead and do that. Okay, so pi squared is approximately 3.14 times 3.14 is approximately 9.8596. 9.5 is 9.5, and we have 9.8, which is obviously just 9.8. Okay, and then you have 9.5 repeating, which is just 9.5555 dot dot dot. Okay, it keeps going on forever, right? Okay, and now we have the square root of 94. Okay, so what you're going to do to approximate this is you're going to do the same thing that we did up in the previous examples to get this. You need to figure out what two perfect squares 94 is between and go from there. Okay, so in approximating the square root of 94, here's how I did it right here. Same thing we did a while ago in the examples, and it is clear that the square root of 94 is closer to 9.7 because 9.6 is at 92.16 and 9.7 is at 94.09. So I'm going to go with it's approximately 9.7. Okay, so why are irrational numbers being written as their rational approximations? Why do we do this for pi squared and for the square root of 94? Okay, because we want to compare these irrational numbers with the rational numbers, and so they need to be placed on number line with the rational numbers, so therefore we had to make them rational approximations. Okay, so now let's do that. Plot each approximation on a number line. Okay, so let's look at this. All right, the first one I'm going to do is pi squared, which we had at up here at 9.8596. So basically almost at 9.9. So let's go down here and write that. So that's going to be right here. That's pi squared. Okay. The next one I'm going to do is 9.5. That's pretty easy. Just come right here and put one on 9.5. Okay. Our next one is 9.8. So I'll write that one right here on 9.8. Okay. Now let's talk about the next one, 9.5 repeating. I already have a 9.5. So where will 9.5 repeating go? It's going to go about right here. And so here's my question. Why, that's right here, why is 9.5 repeating greater than 9.5? Okay, so 9.5 repeating means, with a bar over it, means that it repeats forever. So the number 9.555 keeps going, is greater than 9.5 because 9.5 has a 0 in the hundreds place, while 9.5 repeating has a 5. Okay, so and now we need to plot our approximation of the square root of 94, which was at 9.7. Okay, so right here, and this is the square root of 94. Okay, so now that we have this, we can order these in order from least to greatest. Okay, so we have that now. So let's write our answer. So here is our answer. So 9.5 is less than 9.5 repeating, which is less than the square root of 94, which is less than 9.8, which is less than pi squared. Okay, so let's look at this one. I want you guys to try this one and then just write these where they go in here. Show your work down here, and we will then pause the video, do this by yourself, and then unpause and check your answer. Okay, so here's the answer for this one. Check your answer, make sure you got it right, and then I want you to move on to find this one. But here's this answer. Here's the work, and here's the final answer. Okay, so pause the video and do the very last one. And then after you do the last one, I want you to read the key concepts, okay, and then work the review problems. And I will give y'all the answers later to check over it. So after y'all done this, then you need to get started on the closing task. I'm sorry, this is the closing task, my bad. All right, so finish this review and then you can start on the homework.